Okay, so I know we probably saw this figure when you guys were doing all those ones yourself, kind of figuring out some things. So I might use the same figure again or another one that's in here, but just ask a different question about it. So you can make up millions of questions. All right, so what we're going to do is go ahead and put this into y equals. Okay, so now when I need it, I'll have it. Also, we're going to try, and I told you this, but then I keep forgetting to do it. We want to go ahead and figure out where they cross. We need the boundaries. So it tells you in the problem that this is the line y equals 4. So we can go ahead and type that in also. Now I'm fairly certain that that one intersection point is the point um, 0, 4, but we could double check by looking at the table. Yeah, it definitely is 0, 4. The other one doesn't cross at an exact point. So what we'll do is find the intersection point. Second, trace 5. Move close to it. Okay, so that's going to be 2.3. Now, if it had been some crazy decimal that went on and on, you probably would want to represent it as A. But since it's no big deal that it is the point 2.3, I would just use 2.3. It would take more time um, to just store that for A or whatever. Okay. So now every time that I'm writing and I need this curve, I'm just going to call it f of x. I'm not going to write out the whole thing. And then when I put it in the calculator, I'm just going to use y1. Okay, so A says to find the volume of the solid generated when r is rotated about the horizontal line y equals -2. Okay. So I'm going to draw that line. It's not going to be very accurate of like where it actually is. It would be way lower than this, but we're just going to pretend that this is y equals -2. All right. And then this is the region that I'm rotating. And you'll notice that there's a gap between the, the axis of rotation and where the figure actually is. So this is going to be a washer. All right. And so on washers, we have the outer radius and the inner radius. So I like to go ahead and draw it from my axis of revolution. Now, I'm not sure about this. Us calling this capital R, it makes me a little nervous because there already is a capital R in the problem. So when you're doing your work, if this happens on the AP test, you might want to just like let the person knowing that you're talking about a radius when you say what R is. Just let them know you're not talking about the shaded region R. Okay. So to figure out that radius, if you guys remember, well, first, is it okay leaving f of x the way it is, or do I need to try and solve it? we're good. If it's a vertical radius, we're good. Just leave it like it is. That would be really difficult anyway, just the way the function is. So we're going to leave it like it is, and we're going to do top minus bottom. What is the top? And what is the bottom? No. All the way to the bottom of the green line. Where is that?
Oh,
-2, yes. All right, so that radius is always going to be 6. Like everywhere in this rotated region, the radius is going to be 6. All right, and then little r, what's the top? F of x, and we're just going to call it f of x. We don't need to write it out. And then we're going to subtract -2 from it. Now, if you wanted to leave it minus -2, you can. I think you're more likely to not make a mistake if you just go ahead and change it to +2. All right, I didn't give you guys a ton of space. I'm sorry. I know this. We may have to write our work for B somewhere else. Okay, so now we need to set up our integral. Since this is a revolution one, it's forming circles. It's forming a radius. So we're definitely going to have the pi. So it's pi r squared dx, basically. Well, actually, bless you. This one has the 2 r's, sorry. It's going to be big radius squared minus little radius squared dx. Oh, I forgot something. What are my upper and lower limits going to be? Okay, so we're filling in all of these. Yeah, right. So we're filling in all the little radii. And so we're going from left to right, or try to remember that if these are x's, these have to be x's. And so the x's are from 0 to 2.3. Okay, so let's type that in. For f of x, we're just going to use the y1. Right, this one you have options on how you can write it. So we can either truncate at the 7, just drop off everything else, or we can round the 7 up. They're both 100% correct. So it could be 98.868 or 98.867. They're both perfect. All right, any questions on that revolution? Okay, then B is going to ask for like what we did yesterday. So we still have this region R. For this solid, each cross section is perpendicular to the x-axis is an isosceles right triangle with a leg in R. All right, so what this means is you're going to fill up this with an isosceles right triangle. I'll do that a little high. And it's going to form a shape. It's kind of hard to visualize. I'm going to go up here to do B. On your test, I'll give you plenty of room to fill in all the stuff you need. Okay, so what I would do on these cross-section figures is I would find the area of one triangle or represent it. And all the other triangles are going to follow the same suit. All right, so the area of a triangle is 1/2 base times height. In this case, the base and the height are the exact same thing. All right, how would you represent the base of that triangle? It's just going to be top minus bottom. So it's going to be 4 minus f of x. And since we're doing base times height, and they're both the same, what would I do with that? Square it. Good. All right, are you okay with that? Ish. So that's one triangle. We have to add up all of them. So it's going to be an integral. Now that 1/2 can go inside or outside. Do you guys have a preference? Outside? Is that what you said? I swear I'm losing my hearing. Okay. What are we going to go from? Do I have x's or y's in this problem? X's. We're going to go from 0 to 2.3. And then it's going to be 4 minus f of x squared. Whole thing squared. Dx. All right, you guys type that in. Now you can't put a square on their parentheses when you type it in, so make sure it's all that stuff inside their parentheses. So you can, basically you have to type it like that. So I think you should get 3.574 or 3.573. Which I've got. Okay. All right. So all the rest of them are going to be similar to these. There'll be an average value for sure thrown in there, and so you can look that up. I'm not going to put any of the semicircles, ones like this, or isosceles triangles. Equilateral triangles. It'll be either squares or isosceles right triangles. So the ones that aren't, it's hard to remember the formulas.